Okay, let's continue. So we're now in chapter 4. So we already done the equation of impulse and momentum. So this equation that we've seen yesterday, we'll repeat again for today. So we'll involve impulse. Impulse means your force, you integrate force with the dt, you get impulse. And then on the right hand side of the equation, you get momentum. And then you rearrange mv1 plus impulse equal to momentum after. So this is what we have discussed yesterday. And this equation only works for individual objects. You don't mix everything into one equation. Right? Okay, today we look into conservation of linear momentum. If you see the word conservation, it means that there's no change of energy, there's no change of momentum. So here, our impulse, our sum of external impulse will be 0 if the question asks you to consider conservation of linear momentum for the system. Okay. So you just write the equation and then you cancel the middle one, the impulse, because you want to conserve the momentum. Okay. So you arrive at momentum before will equal to momentum after. So all the mass multiply with velocity before will equal to all the mass multiplied by the velocity after. So the I here means individual. This is momentum. So if the question again force you to consider conservation of something, in this case conservation of momentum, linear momentum, then you write this equation. Okay. So on the left hand side, if you look at the object, if you see Vg means we look at center of gravity or center of mass of that object. Okay, center of mass of the object. And if you sum all the mass together, it will be the same. So the m on the left hand side was same as the m right hand side. So you have velocity before will equal to velocity after. Okay. So this it just means that velocity of the central mass or mass center, right, will be the same, does not change if no external impulse is applied, because we take away the linear impulse, right? So if no change of external impulse, then the central gravity velocity will be the same. Okay, we look at example 4. So on the diagram, we have two objects or two containers. One is moving to the left, one is moving to the right. A moving to the right, B move to the left. And both move in the different velocity. Okay. Again, chapter 4, you are required to use principle of impulse and momentum, which only deal with force, time, mass and velocity. Okay, if the chapter 4 question come out and you use chapter 1, chapter 2 equation to solve, then you are going into a wrong direction. Chapter 1, chapter 2, you are solving with F equal to ma, you are using acceleration, but in chapter 4, you do not use acceleration. You are only consider velocity. Okay, so here, look at the question, 15 megagram. So mega, you need to convert into unit SI in kilogram. It's costing at 1.5 meter per second on the horizontal track. So this is a linear motion. And encounter a 12 megagram costing at so and so. If cars collide and coupled together, means it joined together. Okay. Determine the speed of both cars just before coupling. So before it join, you need to find the velocity before it join, and the average force between them if coupling take place in 0.8 seconds. So here you are given time. You need to find force. You have the velocity. So this is chapter 4 question. So chapter 4 means you consider force, time, mass, and velocity. There will be one of the parameter is missing. So if you look at the question, if you find force, means you're given mass, you're given time, you're given velocity. So you can solve using the principal linear impulse and momentum. Okay, so you need to draw free body diagram. So A is both car just after, not before. Just after coupling means they join together. So when joined together, the chocolate box will join with the gray box. Right, makes sense, right? However, the force is a bit different. So you need to identify your direction, your positive direction. In this case, we will look at the diagram, 1.5 meter per second and 0.75. I will recommend always use the higher value of velocity as your positive direction. Okay, so in this case, as you can see, the blue arrow force for the purple block is positive to the right. And then the gray color is moving to the left. And we have the minus F. Okay. So we put in the kinematic diagram. Yesterday in our class, I did explain on the whiteboard what is kinematic, what is kinetic. So this is kinetic diagram. So we combine the kinetic and the free body diagram. Okay. So in this case, momentum is conserved in x direction. Okay. So since the coupling force F is internal to the system and will therefore cancel out. So you write out the equation of principal linear impulse and momentum. And if the two objects join together, you straight away use conservation linear momentum. You straight away, you remove the central, the middle part of the equation, which is you remove the linear impulse equal to 0. Because the two force cancel each other when you join them together. Right? And once they join, you need to estimate the final direction. When the two objects join, in this case, purple blocks move faster, gray blocks move slower. So faster meets slower. The faster one will push the slow one. Okay, so the V, that's why the green color arrow is moving to the right, positive. So we assume after collision, we have a positive direction V to the right. V2 will move to the right. Okay, this is the way we solve. So first, you need to identify your positive direction. What happens if two car is join? Okay. Example 5 later, we will discuss what happens if they do not join together. I give you one example of this one, coupled. Coupled. Okay. Once it coupled, you can use conservation of linear momentum. Conservation linear momentum, it depends on how many objects you have. In here, we have 2 objects. So each object have 1 momentum. So you have 2 objects here, A and B. So you write MAVA1 with before, plus object MBVB1 also before, equal to, need to look at your diagram. The right hand side is what happened after. If it's coupled, means the both mass will join together. M1 plus M2, means MA plus MB. If it's coupled, then you use bracket to join the 2 mass together. And then you have a V2, same velocity. If it's coupled, if it's not coupled, if it bang and then breaks away, then you have 2 different mass and 2 different velocity, because you bang and then it move in the different speed. In this case, it's coupled, so we have this direction. And remember to tell me where is your positive direction. It's important because we're dealing with vector. Velocity is a vector. It's important. So in this case, 2 are moving, hit together, and then move to the left. Move to the right. That's why you see all positive value here. If it's hit, if we switch the velocity between A and B, if the gray faster than the chocolate color, then your velocity here will be negative. This one will be negative. Okay. Okay. So here, okay, here you put in all the value. I suspect VB should have negative there. Okay. Yeah. You check, help me check. Maybe some typo error in my slides. There should be a negative 0.75 there. You need to press calculator. I'm not sure whether you get this 0.5, right? So there's some typo error in my slides. Okay. So this is how you find. Now we have solved the first one. A is a coupled, and then you find the velocity moving together. Means you use this equation, and then just need to be careful on the direction. In this case, there's typo error. VB, because VB moved to the left, it should be minus 0.75 and not positive 0.75. Okay. All right. So for B, average force between them, if the coupling take place in 0.8 seconds, means the joining process takes 0.8 seconds to complete. So you just need to take one, either chocolate or the gray color. We took the chocolate color, and the force is minus F. What minus F? Because you need to imagine you're the chocolate one, and what do you feel in your face? You feel something hitting your face. That's why the force is pointing to the left. Yeah. You hit something, something is meeting in your face. So same like the normal force that I discussed in the class yesterday. So don't simply put your arrow somewhere else. There's a meaning where you put the force. So here you have negative F pointing to the left. So we use principle of impulse momentum, and again, when you use principle impulse and momentum, you are referring to individual body. You're referring to individual body. So here we're looking at A. So MAV1 A plus the impulse FT equal to momentum after MV2. So here you put in all the known value, mass, velocity. F is minus because it's pointing to the left. Time already given, so you don't need to integrate. Time is 0.8 seconds. Unless the question asks you a range. It asks you average force between them if coupling take place in from certain second to another second. Then you need to put in the limit here. Yes. $15. Yes. Because you need to use unit SI. You need to use unit SI. Yeah. Okay, average force you get is 18.8 kilonewton. The direction for object A is to the left. Okay, the direction. If I draw like this, my force is positive. It's not negative. Negative means the value when you substitute into equation. Understand or not? So when you draw diagram, if you're pointing to the left and the positive to the right, you don't need to put in negative there. I put in negative just to remind you that the force value is negative when you put inside here. Understand? So when in the test if you point to the left and don't write negative F, it should be F. If you put negative F means you flip the arrow already. Understand? Yes. You can do for B also. Same. Only the value will be, if you do for B, mean MB, and then this one F same. But F is pointing to the right. And it's positive, not negative. And velocity V2 for if you do B, V2 will be positive. Only VB will be negative. So just be careful on the positive negative. All right. Okay, now we look into what happens if you collide and then the two objects break away. So you play bumper car before. So you have you have car A and B bang into each other. So you know that a bumper car doesn't join together unless they both come to a stop. So VA 3 meters per second, VB will be 2 meters per second. What will be the estimate motion? What happened to A after bang, after hit? Is either there are many possibilities. Either it will stop, either it will continue to move, or it will move to the back. There are three possible motion. Okay. B, we have two possible motion. Either it stop or it move to the back. Okay. So you need to draw free body diagram. You draw A and B. The question asks you velocity before. Okay. If no energy is lost, it means you can use conservation of energy. No energy loss. Determine the velocity after collision. So you can use conservation if you want. So you draw the two object A and B, and then draw your usual free body diagram and kinetic diagram. Put in the weight, and then there's a contact. So this will be the careless mistakes every time. When it comes to chapter 4, you will forget the contact normal force. Then there are two forces there. There are two forces there. You should know which one and which one. Sorry, it should be WB, not WA. On the green color one below there is WB. Both has MS, yes. But you can label WB. It should be WB, not WA. WB. Okay, so you should able to identify. This red color force is referring to A. You have to imagine yourself if you are bumper car A. If you bump to something, the force is pointing into your nose, into your face. The force is into your face. So this red color force on the right is for A. For B is the left hand side force. You have to know which one and which one. And each force is different. Okay, we can use conservation of momentum because there's a tagline there. If no energy is lost, this is a keyword there. If you see no energy loss, you can straight away use conservation of momentum. Okay. So here you have momentum before equal to momentum after. Momentum before, you have two objects before collision, and after you have two objects after the collision. So you have MA MB equal to MA plus MB. Okay. If the two objects join after collision, then on the right hand side you bracket the MA plus MB, and both move in the one speed, same speed. Yeah. The rest you substitute, you're able to find what is missing. Okay. So you substitute. In this case, mass is in kilogram. Just take note on the positive negative sign. Your positive direction is to the right. Positive to the right. So VA velocity positive, VB is negative -2. So this is the careless mistakes. So just take note. Every time you need to refer to what is your positive direction. Because you're dealing with vector. Okay, once you have one equation. VA2 equal to 1 minus VB2. Okay, we have one equation, two unknown. We haven't finished the solution. Okay, so this is conservation of momentum in chapter 4. And you see, if no energy, the word energy there, you can use conservation of energy. Because you need one more equation to solve this equation. Right? Now, there are a few types of energy only for dynamic. Kinetic, potential, spring. 3. Okay. Kinetic, half mv square. Kinetic, half mv square. Potential, related to height, mgh. Spring, half. Okay, always positive for spring. So here, there's no spring, so no spring energy. There's no changes of height between the two cars, so no potential energy. So only have kinetic energy. So only have three kind of energy for dynamic, spring, kinetic, and potential. Okay. So here, we have seen this one in chapter 3, conservation of energy, the last section. So if you have missed this one, go back and read the slides. So conservation of energy, kinetic, all the energy before will equal to all the energy after. Before you have three type of energy: spring, potential, and kinetic. So here you don't have spring. So you have potential. T1, T is kinetic. T is kinetic. V is potential. So energy before equal to energy after. You put in the equation. Basically, the potential is zero because there's no change of height. There's no datum given. Okay, so you put in energy, kinetic energy before half mv square. You have two objects, so each object have kinetic. So label carefully, label carefully before you substitute your answer. The next step is just substitute the value given in the question. M you have V1A, V1B you have. Then you arrive at one more new equation because you don't know VA2, VB2. Yeah, substitution. You get VA square plus VB square equal to 13. You have two equations. Equation 1, equation 2, solve simultaneous. Either sub, either, the fastest one is substitution. Yeah, I skip the mathematics part. You substitute there. You get a quadratic equation. You substitute inside, then you get the second equation. And you solve for quadratic equation. You have two roots because you have square quadratic equation. So you have positive, negative answer. You need to choose the correct one. Okay. So you have positive value of 3 and negative 2. What do you think which is the correct answer? This is VB. If you choose 3, why 3? If you choose minus 2, why minus 2? Okay. Okay. This VB actually is a velocity of B. You have two velocity in the for B. Either you are 2 or you are 3. So before collide, you're already going to the left 2 meter per second. So this is before. Because your velocity of B object B move in the quadratic behavior. Okay, your VB velocity of object B move in the quadratic behavior. So you only have two velocity when it is 0. Means if you plot the graph, the maximum speed or minimum speed will intersect at 3 minus 2. Not maximum minimum, but you will intersect these two roots. Okay, so we choose 3 meter per second positive value, and you move to the right after it meet A. Yeah, so this VB2 square minus VB2 minus 6 equals 0. This is the equation, velocity equation for B. And you should able to read and understand what this equation means for the velocity. You substitute back 3 into the previous one, you get VA2, which is 2 meter per second to the left, because you get negative value. Yeah, you substitute 3 here, you get negative value. Negative value means something. You need to change it, translate it into a layman term. means you convert into positive value and then you tell me what is the direction of the object A. Yeah. So this is the objective of learning dynamic. Means you're able to imagine what happened after something happened. Where does the object go? How the object behave? Does it stop? Does it continue to move? Or does it leaving the surface or something? So this is the purpose of learning dynamic. Okay, next, this one is more on the civil side, but still related to dynamics. So if you have a piling projects, you do piling, and you have a hammer hitting the pile, go into the sand, and you're given a datum. The height is 0.5 meter. So be careful when every time you have a datum, you need to consider energy already. Every time you see datum, something moving on top or below, do consider potential energy. Because you have H already. You have H, so H will give you mgh, will give you potential energy. And something moving with the velocity will give you kinetic energy, half mv squared, unless the object do not move. Then if there's a spring, then spring effect. Okay. So you're given mass of the pile and using 300 kilogram hammer. Hammer fall from rest. Fall from rest means you already have your V1 of the hammer at the height of so and so. Strike the top of the pile. Determine the impulse. It asks you to calculate the impulse first. So if you see the impulse means you call the principle of linear impulse and momentum equation and then solve for the impulse. And every time you use principle, linear impulse and momentum, you are referring to individual object. Then you solve the equation. The power exerted on a hammer, if the power is surrounded entirely by loose sand, means it do not bounce back after striking. The hammer does not rebound off the pile. So this is an ideal case, but usually it will bounce off. So we are still at dynamic chapter 4. Later, when we consider energy, we will consider bound off scenario. This is do not bound off, means you hit, it will just hit like that. It will just touch like that. Okay. So you need to find the impulse. Impulse, you need to, before that, you need to draw free body diagram. Okay. The hammer does not rebound off, means is hit and stay. If you look at this diagram, you should be able to identify which arrow referring to which item. The bottom arrow is referring to the hammer. The top arrow is referring to the power. You need to reimagine yourself as an object. What do you feel in that incident? So you have a R and positive R. And in this case, we follow the motion of the hammer, go down positive. Because here you see the datum, it do not give you the positive direction or negative direction. It just tell you the height. Not like the pulley system. So this one, it gives you the height, but you know that the hammer is above the datum. So for the free body diagram, always follow the motion. Always follow the motion, positive direction. So here our Y go down positive, following the hammer. And the power also go down, actually, go inside the sand. So our object, our focus is on the hammer. You focus on, don't focus wrong object. Here we focus on the hammer. Velocity positive go down. Okay. So force rebound from the soil is 0 because you are having a loose sand. So there's no force filled by the pile. It lose sand, so it continue to go down without any resistance. So there's no resistant force from the sand. So no zero. The weight of the pile also not considered because loose sand is free fall. It's like a free fall. Okay. Okay, so you just put a note here. The hammer and pile and the resistance of the force of the sand are non-impulsive. Impulsive means it do not hit and then it bounce back. Impulse means you hit and then something happen. So impulsive force R is internal, so it can be cancelled. Because it do not bounce back. The whole thing do not say that it go other direction and so on. Okay. This also same. If you work for outer space object or satellite object later, intercept, when you have two object intercept, this is, let's say this is ISS, this is your satellite or this is your cargo. When your cargo reach ISS, it will just join like that. Will just join like that and then move together. This is non-impulsive lah. So just join and then move together. Okay, so conservation of momentum, we use MV before, MV after. So we are having two objects here, hammer and a pile. So A replaced as hammer H, B replaced as pile P. And we know that number 2 velocity after will be the same for the hammer and the pile. So we simplify the equation. VH2, VP2 will equal to V2. Because when they hit and then both go same speed. This is a collision this is a coupled condition. You hit and then go together with the same speed. Of course, if this question come out in the test, I will give you hints in the statement there. Both objects will go together at the same speed. Or I will just say coupled after certain action. Okay. So you substitute, you'll find your V2 is 0.85 meter per second. And you go and you get positive value because both objects go down. Yeah, go down. So for dynamic, always at the end of the question, you need to answer what is the direction of the object after the effect. Okay, so the rest is just for your info. The rest just for info. So this one, if you use a principle of impulse and momentum, this is hammer. Hammer. R is what it feels if we hit the pile, or you can put as F if you want. So you can use conservation of energy also. Conservation of energy because you have velocity, you have kinetic, you have height, you have potential. There's no spring, there's no bounce back, so no spring force. So you can use this equation, half mv square plus mgh. Your h is yo, positive. Positive is because it's above datum. Energy is a bit different. You need to be careful on the energy, especially come to datum. Potential mgh, you are having positive potential when you are falling above the datum. If you start below the datum, you get negative potential. So that's why this equation on the right hand side, you see the potential is 0 because it stopped at the datum position. mgh at the after the hit is h will be 0. Your y1 is 0. That's why your potential is 0. Okay, so you put in all the value, you get your v1. Okay. So imagine this question can be modified, become a satellite space question where a cargo parked into ISS is the same. It's the same scenario. Your datum will be the door of the ISS. Okay, the rest you read. The rest you read. Okay, so the rest you read. So this one is your homework. You go and find, just substitute and find the R component. Impulse. This is impulse. It means impulse force multiplied time is Newton second. This is force, but the question asks you to find impulse. The previous step is to find the V1 and V2. And then the last step is to use conservation of, principle of impulse and momentum. The impulse, you don't know. So you just move the momentum before and after together, and then you find the final value. Okay, we move to a new section. Can continue? Or you need rest? Continue? Okay. 4.4 impact is very friendly to those playing snooker. If you're very good in snooker, then this is your favorite part. Okay, so impact means two bodies hitting together, causing impulsive force between the two bodies. There are three types of impact. The first type is called central impact. Central impact, you need to draw the line of impact. Every time when the question about impact, you need to draw where is the line of impact. When the two bodies hit together, you just follow the velocity line. You pick one object velocity, and then you draw the straight line. Sometimes BB will be different. BB will coming from certain angle. You pick one of your focus object, and then you draw line of sight, a line of impact. And then when the two objects hit, you have a plane of contact. So these are the two lines that you need to draw every time you have an impact. Plane of contact means there's a 2D glass, like two objects hit together. Okay. And there's an object A, object B, and velocity A will always move to the left, right? B will move to the left to have impact to happen. Okay. Okay, central impact is along the line of impact. The second type is called oblique impact, which is the favorite in your test 2 and final exam. Okay. You observe if your test 2 I ask you central, your final exam you will see oblique. If I ask oblique in your test 2, then final exam you have central. Okay, so oblique, it means both come in at the angle along the line of impact, but different angle relative to the line of impact. Okay, relationship between the plane of contact and line of impact always 90 degree. Plane, contact, and line of impact always 90 degree. Yeah, so there are two types, and observe the angle on the diagram. This symbol lah. And then another one also, this is phi or something lah. So there are two different angle you can label as theta A, theta B, and so on lah. But there are two different this one. Okay, there are two motion, two impact, central and oblique. Central or oblique. Okay. So each set will have different equation later on. Okay. This one, you solve only one equation, where is you look at x-axis. This one, you need to break the motion into x-axis, y-axis. Okay, we do central impact first. Central impact, you need to imagine how it happened. You need to know before, hit, and then after. Three scenario you should able to draw before, hit, and after. If it's oblique, how it is. If it's central, what is it? So this is central. So you have object A, object B. A and B move in the same direction. In this case, same direction. But speed of A must be higher than B so that collision can be happen. Impact can be happen. So when it hit, when A chase B bump together or collision, the phrase is called deformation or impact scenario. So if two objects meet together, you see the form. The form is a bit squeezed together, not round anymore. They are squeezed and have a bit long shape, long oval shape. So when you squeeze something, then there's an impulse happen. When you squeeze something, impulse happen, and you should able to identify which one is positive, which one negative, by imagining you are that object. And we always assume to the right is positive, following the motion. To the right, positive. So this minus P is on the left-hand side A. Impulse at P minus PT is for the A. Positive PT is for B. Because the force felt by that object is accordingly. So these are the keywords that usually come in the question. To ask you, analyze the effect of something on something. So for example, this one, effect of A on B. On B means you are B. What do you feel? Okay, so you have to know which one is which one. Okay, so you have deformation. So deformation, you have impulse. So if the question focus on deformation, basically you are calculating the impulse. You focus on impulse. And then when it hit, then you'll come into a maximum deformation. Maximum deformation means two objects go together. They will squeeze and go together in the same speed. Yeah, maximum deformation is only one process, not yet finished. Not yet finished. Maximum deformation, go in the same speed. After that, you squeeze, right? And this one is elastic. You can assume as an elastic, so it will kembang balik. It will go back its original form because you do not destroy it, right? You do not destroy it. So longitudinal oval shape will go back to the round shape. It's called restitution. Reinstate. It reinstate, restitution, impulse. So it'll go back to its original shape. Again, effect A on B, effect B on A. you have to know which one is which one. So we label as R for restitution, P for deformation. We use P for deformation, we use R for restitution. So you have to know which one is which one. This is an impact question. We either ask you before maximum deformation or after maximum deformation. Okay. So it will. So there are two scenarios at the restitution or reinstate. It will either return to original shape or permanently deform. There are two scenarios. After this one, after this restitution, either continue back to its shape or permanent deform. And this is the impulse that push the two objects apart. This is the one that push apart. Restitution is the impulse that push apart to break away. But this one, deformation is only towards maximum deformation. This one, this impulse PT is to make sure is maximum deformation and go together in the same speed. But restitution is to break away the two objects. There are two cases, either permanently deformed or original shape. Okay, in practical, this is if you do experiment, the deformation, this one, the P deformation impulse will be more than the restitution impulse. Okay, you hit, before you hit, you have the highest energy, you hit the P will be higher than the R. Because you already use energy for deformation already. That's why your energy, your impulse will be less. Then it'll break away. Okay, it'll break away. Usually after impact, B will move faster because you transfer the energy to another body. B will be faster. Slow object become faster object. Fast object will become slow object. Slow velocity. Okay, so this will be the scenario with when we have impact. This is a normal impact, normal process or impact. So you need to identify the phases. So also there are some words there in the question. You will see final momenta. Momenta means final moment. Final moment, what happened to that object? Okay, so the question can be make a statement of the after the impact or make a statement for final momenta according to your analysis. So it means you need to draw the two objects and then tell me what is the velocity before and after. This one V2, VA, VB, what happened? Is bigger or smaller? And then the momentum on the object. Okay. And when you draw, because it's momentum, so you can represent by the length of arrow. If the MVB is more, momentum is more than longer. Yeah. Okay, the rest you read. Okay, in most problem, you'll be given the initial velocity. In this case, momentum for the system particles is conserved because we have deformation and restitution. Both are cancel each other, the impulse. Because we use the word conserve, we assume conservation happened. Okay, these two, deformation and restitution, the impulse, we assume momentum, right? Momentum is conserved because we assume the impulse is conserved, is cancel out each other. So we can use conservation of momentum. If the question mentioned, if you see the word conserve or no energy loss, then you can use this equation. Yeah. You look at this question, you see MA, MB, MA, MB on the left and right means the two objects break away. If the two objects stick together, then on the right hand side after will be bracket MA plus MB and two move in same velocity. Okay, there are two sets of equation. Okay, so this is a derivation. You just observe. I won't test you this one. I won't test you, just for observation. So this is for deformation, particle A. So you can use principle of impulse and momentum for A. So mv1 plus the linear impulse, y negative, ya negative for impulse. Because force, the A is feeling something pressing in, your force is going back. Your positive direction is to the right. That's why negative here. But the original, the general equation is positive. And then MAV. So we have one equation for A. For restitution, also same. You use principle of linear impulse and momentum, same. MV, but in this case, you already know your V. This is on the restitution. Restitution, because restitution, you already know your two objects move in the same velocity already. So your V here is not VA, but it's a V. And then minus R, because same thing. The R is going to the left. And MV VA2. So we have these two equations. One is deformation, one is restitution. What is different is the velocity on the left-hand side and left-hand side. And then the P and the R. Equation 1 on the top and below, you need to refer to the diagram just now. Deformation is before they squeeze into maximum form. Restitution is after squeeze maximum form and then break away. We derive the one more equation, which is called coefficient of restitution E. Okay. This is a new equation. Coefficient of restitution, it means you take after divided by before. You take after the maximum squeeze divided by the before the maximum squeeze. You take restitution impulse divided by deformation impulse. This is a new equation for dynamic for this module. A new equation for today, for chapter 4. The rest you keep repeating the principle of impulse and momentum. This is a new one for today. Okay, so these are the equation. You need to see the diagram. You need to draw out the diagram, and then you take these two, divide each other. You are finding the missing parameter inside there. This one sometime will be given or not given. If this given, this V will be missing. This V will be missing. This one you know, this one you know, this one will be constant value. Yeah. So if you put in all the equation together, I skip the derivation already. I skip out all the derivation. At the end, you arrive at this equation. V minus VA2 divided by VA1 minus V. This one derived from these two equations. You simplify, you get this equation. And we cancel out this PT and RT cancel out because we conserve the impulse. And this equation is important. This equation is important. E equal to V minus VA2 divided by V1 minus V. This one is for A. This one is for A only. This set is for A. B is another set. So don't memorize. Don't memorize. Memorize equation 1, equation 2, this equation. You need to put in the equation and summarize here. Then only you arrive at this one. Not necessarily this one. Sometimes it can be positive, can be negative. Depending on your axis. This only works for the example that we discussed just now. Means two objects go in the same direction. One faster, one slower. Hit, and then one go faster, one go slower. You get this equation. It will be different if two objects go head by head. You cannot use this one. It's a bit different. And, yeah. Okay. So you do the same. I will not go to the B. It will be the same process. You can see you get a bit different structures. I will skip all the derivation step. I straight away give you the final answer. If you do for B, you do all the steps together. You will arrive at E equal to B2 minus V divided by V minus VB1. But there is a trend there. There is a format there. If you observe left hand side and right hand side, you can identify a pattern of the term there. The top this term is always the maximum squeeze velocity. This one. Same with this one also. This one is after. Right? So A and B a bit different. Okay, if unknown V is eliminated, so these two, if we don't want to have this, if we don't know this V, because both equation on the left and on the top one, you have the unknown V, we can eliminate by simultaneous equation and substitution. There's a long process. At the end, you arrive at this one. E equal to VB2 minus VA2. Final velocity of object 2 minus final velocity of object 2, object 1, divided by velocity V1A and VD1. Means on the top is after, below is before. But don't mix up the sequence. On the top, you take B minus A. Below, you take A minus B. Why? Why? Why on the top, you take VB2 minus VA2. However, the below one is you take A minus B. We always take the high value minus low value. That's why there's a pattern there. This one, you take before divided by after, and you always take the big number minus small number. In this case, you assume B go faster. That's why you take B minus the A velocity. Below one, A move faster than B, because then you take big number minus small number. So you only need to identify. You need to identify this one. So this is VA. VB 1 1 V VA 2 VB 2. Okay. So in this case, VA1 larger than VB1. It hit and then A will slow down. You use this form. But if you flip the not flip and okay, at the moment you accept this one first, accept this one first. Okay. What is important? You always take big number minus small number. High speed minus low speed. Okay, I will give you a case that you don't need to derive, right, actually. Okay. Okay. So these are the relative. On the top, actually, we call it relative velocity. Below one is relative velocity. So on the top is just before impact. Below is just before impact. So sometimes I only want you to find the relative velocity just after the impact. Means you only need to find this one. And you already know the bottom one and the E is given. There are two scenarios. After this, we have a break. Okay, because too many info already. Okay. If the question say the impact is elastic. Elastic mean what? It bounce back, like a tennis ball. So you have E equal 1. E equal 1 means straight away you substitute 1 here. But reality don't have. You don't have 1. But plastic impact means it either join together, coupled, or deform. Or stick lah. So if it stick together, your E will be 0. So if it's 0, it's very easy to find. This equation become very easy equation. 0 here, you move the denominator up, also becomes 0. This one will equal to this one. The rest you read. This one you read. This one you read. This one is for the this one you read. A bit lengthy. This one, yeah. Okay, so we have a short break. We continue oblique here. So now it's 12. We continue 12:30 lah. 12:30. 12:30. 12:30.